Okay, let's take a look at this situation and how we're going to get the information we need to solve it. Because we see these two routes on router 2, but when we're pinging the destinations on router 3, the pings are not coming back. Let's say that we want to run a debug on version 3, router 3. Say debug IP packets, one of my favorites. Got to be careful within a production network, but it gives you some great information. So I'm going to run that in a lab environment, and I need some pings to generate some traffic. Now, if I send a ping to 172.12.34.3, that's only 5 packets by default. So maybe we'll get over to router 3 in time to get some information, and then again, maybe we won't. So what I like to do in a situation like this, again, especially in a lab environment, is do an extended ping. And all you do for that is enter the word ping, hit enter. It's going to ask you some basic questions. 12.34.3. And repeat count by default is 5. I'm going to send 10,000 because I'm that kind of guy. And I'm going to say no to everything else. And now they're going to start going over. So if they're getting to router 3, we will see something in a minute with show IP debug. Show IP debug. Let's try debug IP packet instead. I hate it when commands get mixed up like that. So we're definitely getting something, and I will go ahead and do a UAll here in a second for undebug all. And you can see that a whole lot of information just flew in here, etc. And some of it we're going to care about, and some of it we're not. And you can see some of this, rip traffic coming in. We couldn't care less about that. Let's see. Here's a little something. This is what we're looking for, is our packets with a destination of 172.12.123.2, because that means we're trying to send something from the local router from router 3 to router 2. But check out this word, and you can just see the able part. It is not able, it is unroute able. Here's the unroute part, and there's the able part. They're unroutable. Well, the thing is, the packets are getting here. We can see that because right above that, you can see that here's the source, 172.12.123.2. So the packets are getting here from router 2. There's your debug, 34.3. But then when we try to reply to the ping from here with a source of 34.3 and the destination's 123.2, it's unroutable. And we know exactly why. If we take a look in the routing table, there's no match here for 172.12.123.0/24. It doesn't know anything about it. So what can we do about that? We have a couple of options here. On router 3, we could put in a static route, certainly. We've done that kind of thing before. We're not really in the static route business right now. We're not in the sanitation business. We are in the route redistribution business. So we're going to go to router 1 and do some redistribution into OSPF. So if we want that section, that 172.12.123.0/24 network, we got to do a redistribute connected into OSPF. So let's go ahead and get that done. Wouldn't do us any good to put the RIP routes into OSPF because right now there are no RIP routes. If we do a show IP route RIP, there's nothing there on router 1 because router 2 is not advertising anything. So we need to do a redistribute connected. OSPF default seed metric is 20, you know that. And you also know, and here's what I was talking about on the last video, if you just put in redistribute connected, only your classful networks will be redistributed. It's really hard to think of a scenario where that's what you want. So I would just go ahead and always put the subnets option. And now let's see what router 3 has for OSPF routes, and there is the 172.12.123.0/24 network. Note a couple things here, interesting defaults. First off, there's our seed metric of 20 and the brackets, and also that this is an OE2 route. Now, the table tells us there is an OSPF external type 1 route marked E1, and there's an OSPF external type 2 route marked E2, but it doesn't tell us what those are. And here's what those are. An E2 metric only gives you the distance from the ASBR, the router that's performing the redistribution, to the final destination. So it's a little awkward, but that is the default. We do in the OSPF section see how to make this an E1 code. You do it during redistribution, change the metric type. But I just want to remind you of that. Your E2 code is showing you only the distance from the ASBR to the final destination. If you change that code to E1, it gives you the metric from the local router to the final destination. So it looks like we're a little closer to getting where we want to get. Let's go ahead and do a ping. First off, 12.123.2. And it went right through, so that looks good. Let's go over to router 2 now. And what are we going to do about this? We could let all 10,000 pings go through, because you can see what's going on. They're all succeeding. Let me stop that. And there we go. So we sent 1,489 of them. 1,394 of them were successful. The kill there, the kill command, whatever you want to call it, is a Control-Shift-6 twice. That is Control-Shift-6, Control-Shift-6. It's a little awkward the first time, but you get used to it very quickly. You'll pick it up. It'll be second nature to you. So to stop any ping, extended or otherwise, and to stop a trace route, Control-Shift-6, Control-Shift-6. Now, let's check out the pings that would not go through before. That looks good. 172.12, 34.3, and that looks good as well. So that's the thing. You can certainly do what we call one-way route redistribution. The route redistribution does not always have to be two-way. But in so many cases, for you to have total reachability, you need to do two-way route redistribution. You will run into scenarios in more advanced studies and in production networks where you just want to do it one way. So that is the end of this lab, but we got a lot more route redistribution to come. I'll see you on the next vid, and we'll do some more.